Computer. Okay, awesome. All right, hey everyone. Hope you're all doing well. Thanks for squeezing in the time to come to this workshop. I'm sure you guys are all really busy, so I really appreciate it. Today we're going to be going over Git and GitHub, why it's useful, and why every programmer should know about it. Before we get started, this is being recorded, but again, feel free to turn on your webcams. It'll let Anika and I know how well we're doing. With that said, let me actually share my screen. I forgot to do that. Okay. Let me present. Let me minimize this. Okay. Yeah. Yeah. So with that said, I'm gonna turn things over to Anika.
Hi guys, I'm Anika. Like Eddie said, I'm the Vice President of DSC. So I am going to be covering Git in general, how it was created, what it is, and why you should care about it. And then Eddie's going to lead us through a short demo or like tutorial of different Git commands. So this is the agenda, just like an overall intro, how Git is used in production. And then, like I said, Eddie will do the tutorial. And we'll have a Q&A session at the end, but feel free to ask any questions that pop up during the session along the way. You can just unmute yourself or write it in the chat, and Eddie will be monitoring that. So you can go ahead, Eddie. So does anybody know how, wait, go back.
Sorry.
Does anyone know how Git started or who invented it?
Doesn't Git mean an idiot or something in like English?
You didn't know that? You could be correct.
That's a good guess, but all right, let me go on.
Anyone else?
Yeah. Okay.
I heard the founder named it after himself because he thought he was a kid. Okay, so go ahead, Eddie.
Okay.
So Linus Torvalds was the inventor of Git in 2005. Linus is actually known for creating something else that is very widely used today in software. Does anybody know what that is? As a hint, it's a kernel and it sounds like his name.
Is that a system Linux?
Yes, correct. It is Linux. So Linus was born in Helsinki, Finland, and he attended the University of Helsinki. And as his thesis in 1996, he created Linux. And years later, in 2004, he moved to Oregon, where he invented Git. I was reading about Linus, and a fun fact about Linus is that his wife is a 6-time Finnish national karate champion, and I thought that was just really cool. So to answer the question why he created Git, we first need to learn a little bit about what Git is. So can anybody explain Git in their own words?
I remember like it's like you can push and like remove stuff from, it's like a repository for projects and for like collaborating with other people on projects and stuff. Is that right?
Yeah, that's a good description. Anybody else want to add?
I would add version control as an important part of Git. It's like if you're going in a project and you want to see like what previous versions had or like what broke, then you could just go back and look at different commits.
Yes, that's a great addition. So Git, you can click Eddie, is an open source distributed version control system. And to break this down a little bit, Matthew explained version control really well. So it is basically what maintains a history of the changes and who made it and what happened when those changes were made and all of that. Does anyone know what open source means?
Like free to the people.
Yeah, software for which the original source is made freely available and anybody can modify it or redistribute it. And then finally, it is distributed. Does anybody know? Well, this says right there. So distributed meaning it has a remote repository on a server and local repositories on local computers like laptops that are full copies of the remote repository. So an example of these remote servers, one of them is GitHub, but there's also some like Bitbucket or Assembler. I thought this diagram on the right was really helpful in understanding how Git works. So at the top, we have the remote repository, GitHub, and that's where all of the code is hosted originally. And then at the bottom, we have the local repositories. So we can imagine that each workstation is a different person's laptop. And using Git commands, which Eddie will explain in the tutorial, and like we kind of mentioned before with the push and the pull, you can clone the most recent version of the files from the remote repository into your local repository, and then make changes to the files and then push them back to the remote repository for everyone else to access. So if, for example, if your coworker is working on the same file locally, they can pull any updates that you push to the remote repository and merge those updates with your own changes. So that's a really helpful thing about Git. Are there any questions about what Git is in general or this diagram, or any comments you want to make?
So does Git like work like a cloud service or something? Like OneDrive?
It's similar, I would say, but you all have your own branches that you're making off of it. So like if you think of Google Docs, you have like a main Google Doc and everybody's editing it. It's different because you are like copying, say there's at like 2 o'clock, there's a version of the Google Doc. You're copying that onto your local computer, making edits, and then putting it back on the Google Doc. So not everyone's actually editing the main thing right away. You're creating what we call branches to create your changes and then merge them back in. So I don't know if it's exactly like OneDrive, but it's definitely like a place where everything's kept and like controlled almost.
Git is not really like OneDrive, but GitHub is the like OneDrive of Git. There's multiple other online services that you can use to store Git repositories. Essentially.
Yeah, go ahead, Eddie. So,
Okay, awesome.
So why did Linus invent Git? So BitKeeper was one of these other things like Christian mentioned, a type of GitHub that was just not super great. There were a lot of shortcomings. It did offer a distributed system, but mostly there were just so many little things that Linus didn't like about it, and it was really hard to develop on. He was using it to develop Linux. And other than that, in the early 2000s, there was a lack of proper revision control systems. The main system was called CVS, but a lot of people complained about that too. So after 3 years of using BitKeeper, Linus still wasn't getting everything he wanted. So he decided to create his own version control system, which was Git. So in production, Git plays an extremely important role. Matthew mentioned some of these earlier. So has anybody used Git in industry or in internships or co-ops? And if so, how did you guys use it?
I just remember using the push command once.
Yeah, we like kind of stored all of our changes there, and like we had to learn all these like terminal commands in order to like push and pull and like get all the repositories and stuff.
Very cool. Yeah, go ahead.
I was gonna say I took a class here called software craftsmanship, where it was my first time being introduced to like GitHub and Git. But honestly, I really still have no idea like how that stuff works. And the only assignment I turned in on the repository was the last one, because I kept emailing my TA like, I don't know how to use this. Like, please help me.
Yo, I got you. That's what the demo's for.
Thanks.
Yeah.
Yeah, we didn't really cover how to do it in class. It was just like, go do it. So like I think Matthew had mentioned, it maintains a history of changes. So when were bugs introduced, and who you can look at, who wrote the change that made the bug occur, is all stored in GitHub. So you can see a log of all the files that were changed and when and on what commit that happened. So next, Git also allows developers to create a workflow. We'll talk about this more later when we talk about branching. So developers can work on features in parallel, as each developer has their own local repository, like you saw in the diagram before. You can easily review your coworker's code and see the changes through diff files in GitHub, which compares the new version with the file with the old version of the file and indicates any things that were added or removed. Similarly, the QA teams can review features and write tests really easily before things are released. And then finally, Git allows you to release applications in versions. You can group different features together and create a release from the develop branch. And then finally, in production, Git automates processes by running tests or deployment script when code is pushed to a branch. Can anyone tell me what a branch is?
From what I remember, like a branch is like a part, or like if you have like all your code and you branch off of it, you have all that code and you can work on it on your own. And then when you want to make those changes to the real code, you can like push them out. But so the branch is like your section of work.
Yes, exactly. It's an independent line of development. So developers can isolate their work from that of the team members, just like Sarah said. So if you go to the next slide, Eddie, can anyone name the branches in this diagram?
Is it like from like v1.0 to develop? Is that a branch? Or like from the green circle to the light green one?
So
Maybe I can
different.
annotate. Or yeah, you can go ahead. Yeah, my dorm is kind of noisy. Sorry for that.
You're good. If you want to annotate, go for it.
I thought the right one might be the branch. The hotfix.
Is that a branch?
Yeah, so there are actually 5 different branches on here: master, hotfix, develop, feature, and release. So a branch is just an independent line of development. So if master is the default branch name, so that one is deployable, meaning that it contains your production code that is ready to roll out into the world. You never want to directly make changes to the master branch. Instead, you want to create branches off of master, such as hotfix or develop, and make your changes, perform testing, and then merge it with the master branch once you know it will work and not cause anything to break. And they call this forking. So when you're creating a branch off of another branch, it's called, forking. So hotfix is forked off of master. So when you look at the arrows, basically what's happening is whatever's on the start end of the arrow is being copied into whatever's in the second part of the arrow. So if we look at the first spot in develop, you're copying everything that's there, cloning that into your feature. So the first dot of feature, and then the sideways arrow to the second dot of feature, that's where you're making changes. So any changes that you make will occur on this feature branch, but not on the develop branch. Does that make sense to everyone?
Is there a main Git flow? I mean, if there is a main workflow, only one line.
So master is the main workflow, but in general, you're going to have develop as well. So develop is just mirrors master. and it's not actually deployed. So this allows you to know exactly what will happen when you push to the master branch. So master and develop, just think of them as mirroring each other, but master is pushed into production. So it's actually like pushed out, while develop is just kind of like you're developing that branch to see if there's something you want to push to master, and you're making all the changes through develop. And then once develop has acquired enough features for a release, you can fork a release branch off of develop, as you can see in the release part. So this is forking off of that third dot of develop, and then you might make some changes such as bug fixes or documentation generation and other release oriented tasks. And then you push to master, and you want to push back to develop so that master and develop are still mirroring each other.
Sorry, could you like repeat what forking exactly is?
Yeah, so forking is when you are like creating a branch from another, from like, it's kind of hard to, so from master, I'm forking off of master to get to hotfix. And those two dots are identical. But then when you make changes in hotfix and then push it back to master, there's some changes in hotfix that will be passed to master, creating a new version. So it's going from version 1.0 to making a change in hotfix and then version 1.1. So instead of directly doing it on master, you're like creating a copy of it, making sure it works, and then pushing it back to master. So forking is just the process of creating that identical copy and like creating a new branch.
Oh, okay. Thank you.
Yeah, good question.
This looks like graph theory.
So
Sorry. Is that
one
it,
more
or-
thing.
okay.
One more thing, yeah. So hotfix branches are used to quickly patch production releases. It's the only branch that should fork directly off of master. So it's just basically like, oh, there's something wrong in production. I want to fix it really quickly because it's obviously out in production and it needs to be fixed. And then when the fix is complete, you want to merge it back into master and develop, because again, you want develop to mirror master. And then one thing about the tags, so master has the version numbers. So when you push back to master, so the arrows that go from any other branch to master, that's pushing from like hotfix to master or from release to master, those you can set tags for and set a version on it. So if somebody wants to go back to version 1.1, they know where that is. Or if you want your feature to be part of version 1.2, then you want to make sure you identify all the features that are in 1.2 before you create that release branch, and make sure they're all in that develop branch before you fork off and create that release branch.
Wait, can you use like forking and pushing interchangeably, or are they the same thing?
So forking is creating the branch. So going from master to that hotfix branch. And then pushing is the opposite. So you're going from the hotfix to master. So pushing is when you've made changes and you want to send those changes back to the original branch. And then Eddie you'll get like a visual of this with Eddie's demo. But are there any other questions? You've had some great questions, so keep asking.
If not, I can't see the chat or anything. 1 second. But yeah, if we don't have any more questions, actually, I'm going to stop sharing real quickly just to set this up. Okay, share again. Okay, cool. So here I have open Visual Studio Code. It's just another editor. You can write code in, so like, Dr. Java or Eclipse or IntelliJ. It just supports a lot of different, languages, so I prefer this. But let me exit out of the welcome. I've created actually, let me open up the terminal. So now I'm in the terminal of Visual Studio Code, and I'm going to open up in a Finder the folder I'm in. So as you can see, I'm currently in my Git demo folder or directory, which is in my Java directory, which is in something called programming languages. Under desktop, everything's under my iCloud drive. So I'm going to start by creating a new file. And also, for the sake of time, I might be going a bit fast. Feel free to stop me if you're lost at all. We're also going to send out this meeting, so you can always watch it back. But yeah, I'm going to create a new file here. Let's call it git-tutorial.java. It's going to be a Java file, and I should have done this before, but let's just write a quick class. Let's say it's a main function, and let's say that this main function just prints out a hello world, okay? Hello world. Cool, I'm gonna save it, and if I go back to my Finder here, you can see, hey, look, there's a git-tutorial.java. If I preview it, the code is there, right? And just for the sake of the demo, I'm gonna run this file in my terminal. So I can do that by doing Java space the name of the file. And hopefully when that runs, it'll return hello world. There it is. Okay, sorry, that was really slow. Right, okay, so right now, this Git tutorial file is on my local machine, right? It's on my, on my Mac. If I wanted to, let's say, go to like the Mac lab or something, this file isn't going to exist on that computer, right? Assuming that I'm not under my iCloud drive, this file is not going to exist. So what I can do now with GitHub is I can take this file or take this entire project and push it onto GitHub. What this helps with is, again, version control, right? So if, let's say I want to make a bunch of changes to this code, but I'm a really bad programmer and I don't test my code whenever I write it, I'm gonna lose the functionality of this program, right? And a lot of times, I'll exit out of my editor, so I won't be able to undo back to the point where I had my last working version, right? So this is where version control comes to play. So yeah, let me actually open up GitHub. Go to github.com. And yeah, so I'm already signed into my account, but if this is your first time, you can always make an account and come to this page. So what I'm going to do now is create a new repository. What a repository is it's just a place that stores project files, and more importantly here, you can see that it keeps track of revision history. So if I first push a local file onto GitHub with working code, and then I change it to some faulty code, I can always come back on GitHub and see the revision history, right? So yeah, I'm going to create a repository name real quickly. Let's just say description, repository to demo git/github. We're going to keep these preferences, so it's going to be public. And for now, I'm going to not check any of these buttons. We're going to do everything very bare. Okay, so after you click create a repository, it comes to this page. It might seem intimidating at first, but the only thing that really matters is this stuff right here. This is the instructions to pushing your local file, so the file on my computer, onto GitHub. So let me actually move this Chrome browser a bit, and let me pull this back up. So again, these are the instructions I want to type into my terminal. First, make sure you are in the correct folder or the correct directory. Again, I'm in my Git demo directory where I added my Java file. And then, okay, let's just follow the commands to a T. So this line right here, echo pound GitHub tutorial, readme. This just creates a readme file in my directory. So if I hit enter, you can see in my Explorer, I created a readme. Again, in my Finder in this directory, there is now a README. A README is just, I guess, a place where you can add a description to your project, right? So if I double click on this, it has, hey, here's my project name. I can say, add a description, right? So a longer description here. So yeah, that was the first line. And now for one of the more important lines, git init.
Wait, sorry.
Yeah, what's up?
How did you create README? Did you just like create another file or?
Yeah, so you can actually create files in the command line itself. So I created README by doing echo, like this line right here.
Oh, okay, sorry.
Yeah, no, all good,
Yeah.
all good. You can also create a file by doing like touch, right? So like touch file.java. That'll create another file. You can also do rm file.java. Yeah, so learning the command line is really, I mean, it's cool. You can flex on people, right? But no, it
Right.
speeds up the development process too. But yeah, anyways, if I now go to this line, git init, what this does is it initializes an empty Git repository inside of your current folder. So basically, it creates like a place where I can save my added files to, and then everything will be under version control in this folder. So let me press enter. Let's see what this says. Right, initialize empty Git repository in my current folder, right? Another thing you might have noticed when I entered that command is this two right here. So Visual Studio Code is really nice because it has version control or source control, right? So what this does is, again, it keeps track of all the changes you've made to the initial folder. So when I first created an empty Git demo folder, I added some files to it, right? And then everything that was added is now being tracked. So that was git init. Okay, before I do my git add, I'm actually going to do a quick git status. This just gets the untracked files. It tells you, which files haven't been saved yet. So as you see here, the untracked files are git tutorial.java and readme.md. So same as what appears here, right? I'm just going to clear my command line by doing clear, just so everything's easier to read. And now it tells me to do git add readme.md. So what git add does is it just saves a file, or I guess it brings a file from the working area to the staging area. So right now I'm in my working area, right? Like I can do work here. But what add does is it brings everything to my staging area. So let's say I do git add readme.md. You'll notice first under the source control, right? Readme.md is now under my staging changes. If I do git status again to get the status of my files, you can see here, look, there's a new file that's ready to be committed. However, git tutorial.java hasn't been brought to the stage changes area, right? And that's because we haven't added it yet. So I'm gonna just quickly remove the README from the staging area by doing this command right here. So git rm, rm stands for removed, cached, what was in my memory, and then the file name. So if I do another git status, and you can see here, right, it brought this file back from the staging area.
Oh wait, so did you remove README from your GitHub repository or what?
Yeah, so right now, nothing is under GitHub. This is all in my local Git repository. And
Okay.
yeah, I'm gonna write a command later on that kind of provides a streamline between my local Git repository and the github.com repository. So it's really cool. It brings it from my local machine all the way to the cloud.
Okay.
Yeah, and that comes in later, I think this line. But anyways, if I wanted to, let's say, add all of the files that I've changed in my current project folder or in my current directory, I can actually do git add, so the same as before, and then period. Period means, I guess, this current folder. So again, git add period it adds every file in my current folder to Git. So again, if I do git status, now you can see, hey, everything that I've changed or added is ready to be committed. what commit does, really add and commit are kind of like pairs. So to add it, you just bring it from the working area to the staging area. And then when you commit it, you save it from your stage changes and you bring it to your local Git repository. So I'm just going to follow this command right here, git commit -m. -m stands for message, and then you can write, whatever message here, whatever here. All right, cool. Now we see some stuff here. As you saw here, the changes no longer exist in my staging area because they are in my local repository, local Git repository. So if I do git status, everything is clean on my working area. Before I go on, does anyone have any questions?
Can you explain what is the worked space and the staged space?
Yeah, sure. So workspace is just, the editor itself, right? Like I'm currently in the workspace, like it's editing the file. The stage space is anything that, so the stage space, if I push it to the stage space and then I go back to my working area and add stuff, it won't be brought to the stage area. So it's kind of like a checkpoint for when I'm trying to commit.
Does the stage mean that you have already published one version of your code?
Sorry, could you repeat that last part?
Does stage means that you have already published one version of your code?
Not yet. So that would be like committing. Staging is really just, I guess, like preparing your code to be committed. So adding and committing again, like are kind of like pair functions. You need to add it first before you commit it. And committing is, pushing it to, or not pushing, but like getting it ready to be sent off to like github.com.
So can I understand the stage as a saving point?
Yeah, exactly. Yeah, a checkpoint basically. Yeah.
Yeah, thank you.
Yeah, no problem. Anyone else have any questions?
Yeah, I was just wondering, your local Git repository, is it just a file?
Yeah, so let's see. I don't know if my printing, oh, sorry, not print. Okay, so on my computer, I've actually disabled all dot files, but let's see if I can go into my, actually that won't work. Let me scroll up a bit and let me see if I can find when I added, when I did my git init. Okay, so it's not here, but oh, I guess this works. So when I did git init, I don't know if you remember, but like it gave a long message, right? Like created an empty Git repository in the location, right? Like git demo, and then there was a dash and then a .git. This .git file is what is basically where the local Git repository is. I don't have .files enabled here because like they just clutter space in my opinion, but yeah, there's technically another file here.
All right,
yeah.
Thank you.
Yeah, no problem. Okay, so what did I just do? Okay, so I committed, I think. Let me just double check. Okay, nothing's there. So the next command is git branch -m. I'll go into branching a bit later. For now, let's just know to create like to bring your local file to GitHub, you need to have this command. And then right here, this is where I am connecting the two repositories. So my local .git repository will be streamlined to the, edissue, whatever, GitHub tutorial repository. And again, there's the .git file. So this again kind of connects the local Git repository with the cloud one or the online one. Hit that. And now for the cool part, I can finally push everything onto the main branch of GitHub. So let me copy that, enter. You'll be given a lot of, I've actually never read this, but there's a lot of text here. But yeah, the most important part is this part, right? I've sent everything from my local main to the GitHub main. And now if I go back to GitHub and let's say I refresh, all right, this is a bit different, right? So again, the README is just a description, but you can see these two files here, right? With the commit message, when it was committed, and if I click in here, hey, there's the code, right? Yeah, so that's how you commit, or that's how you, would push your local code to GitHub. Any questions there, or can I move on? Okay. Again, feel free to stop me if I'm going too fast or too slow. Okay, so now, actually, before I do something else, I'm going to just go back to my Java file. Let's say now it's the next day, right? And I add some code to the file or to my project. Let's say I add a quick like Boolean function is committed, return true. If anyone here doesn't understand Java, that's fine. You can stick around after. This is just, again, showing version control, right? So showing changes to files. So if I change this code, you can see it marked here, right? These green indicate, additions. Now, if I save it with Command S, let me clear my terminal. I can go back here and see, hey, look, source control, under source control, there's one change. If I do git status, you can see, oh, look, I modified my git tutorial.java file. So now, what if I want to commit it again to GitHub, right? Or push it to GitHub? I no longer have to do that really long process of like initializing stuff and then like streamlining everything. I can just immediately do git add space period. This adds the file to the staging area. If I do git commit with a message, say added method is committed. Right now, there's nothing under my staging area. And from there, I can immediately push it to GitHub because I've already connected my local Git repository to this github.com, like GitHub-tutorial repository. So not to push, I can do git push --all. That's the function to push all your changes. And yeah, again, there's the main to main. So that means I've successfully pushed everything. So if I refresh again with Command R, hey, look, there it is, right? 35 seconds ago, I added a commit. And if I go into git tutorial.java, there it is. There's that function. So yeah, does anyone have any questions about any of that? Okay, if not.
Wait,
yeah.
sorry, I didn't like exactly catch what git add does.
Right. So let's say I add another change here with a space. Okay, that didn't do anything. If I save, okay, I don't know why it's not appearing here, but let me do git status. Right, so there's a modified thing, right? Git add just adds this file from the working area to the staging area to prepare it to be committed. So git add period adds everything in my current folder or directory to this staging area. So the period again just means current directory. I can also, there's a lot of different functions too. So let me exit out of my Finder. There's also a function called open and then period, which opens the Finder. And the period indicates I want to open the Finder to git demo, right? My git demo folder. So if I do that, you'll notice, hey, there it is, right? So yeah, that's what the period is. Yeah, good question though. Okay, cool. So we've gone over the second commit. I guess now we'll go over pulling, so the opposite of pushing, like it is in real life. So the power of GitHub and I guess Git is you can collaborate with a lot of different engineers, right? So let's say I'm working on something and then Anika wants to push some of her code onto GitHub, right? So let's say that we're both co-authors or co-collaborators of this project. For now, I'm just going to hard code her push. Before we would have, if we had more time, we could have demoed her actually pushing code. But for now, I'm just going to go into this file, hit this pencil mark, which means edit this file. This is really bad practice, by the way. Don't ever do this, but let's pretend for now that Anika added this line, right? And let's say, even though she's an amazing programmer, let's say that she made an error here, right? The error is that there's no return type here. And let's just say she wrote that right and then committed it. Okay, cool. So that code is now on GitHub, right? It's under this file. But this file does not exist on my local machine, right? Let's say that she wants me to fix her error. If my local Git repository or my local Git files aren't the same as the online GitHub repository files, I can actually extract all of the online files onto my local machine with one really simple command. Does anyone know what it is? I kind of alluded to it earlier. Okay, so the command is, okay, give me a second actually. The command is git space pull. Okay, wait, sorry, I have to, okay, we ran into a little error here. Let me just commit the changes I made. We might get a merge conflict actually. Yeah, okay, so there's a merge conflict, which is all good. We can fix this real quickly. Okay, all right. So again, the command is git pull. If I do pull, there's an automatic merge. So the reason why I'm getting these errors is because Anika pushed her file to Git tutorial, and I also changed it without pushing it, right? So she pushed her stuff, which kind of changed the same lines as the stuff that I changed, right? So let's see, let's accept the incoming change. So this is Anika's code, right? So, all right, now I've successfully pulled, P-U-L-L, pulled the code from GitHub onto my local machine, right? So now let's say I want to fix this by, deleting this and making the return type void because I don't want to add anything. I can save it, and then again, I can finally push it to GitHub by doing, again, git add, git commit, fixed error. Before I push it, I'm just gonna refresh this. So right now the error is still there, right? And now let me push this to GitHub. Okay, cool. I have my main to main. Now if I refresh this, hey, look, it's all fixed. So yeah, that's polling. Does anyone have any questions about that? Okay, if not, let me go on to, let's see. Okay, so I think that's it for the command line actually. Now I'm gonna show you an easier way of pushing and pulling with GitHub Desktop. You don't necessarily need to memorize all these like commands, only a nerd would do that, right? But yeah, let me open up GitHub Desktop. Oops.
Wait, but which one's cooler, GitHub Desktop or GitHub? Like knowing Git language. I mean,
Honestly,
if you want to impress someone.
Okay, yeah. I mean, I would use Git for that. There's not too many commands to learn. It's just like git push, git pull, like git, add, commit, stuff like that. Yeah, I'll probably send out actually a list of commands and like a description probably after this workshop. But yeah, anyways, now I'm gonna show how you can use this easier version of version control. So this right here is GitHub Desktop. You can download it online, connect it with your GitHub account, and you'll have access to all of your repositories. Let's say for the sake of this demo, I have a third user called Mike, who is a really great programmer and recently joined this project. So with Mike, even though he's a good programmer, he doesn't have any code to work with, right? So you're only as good as the code you're provided with. He can go here to the top left and then add, click add, and then clone a repository from GitHub, right? So let's say that he has access to this repository. He can clone it. Let's say he wants to clone it to, yeah, perfect, desktop, right? Or actually, sorry. Okay, I think I have one of these already actually. Oh no, sorry, I haven't clicked the repository. Let's say I want to go to my, what is it called? GitHub tutorial, right? I can choose to clone this on my desktop. Remember, this is different from this, this directory, right? This is on my desktop under a bunch of folders. Mike wants to have his project on just his desktop. So if I clone it, all right, should be done cloning. Can you guys still see my screen on my desktop?
Yeah.
Okay, cool. Where is this? Oh gosh, I have so many folders. Right here, okay. Git tutorial, right? So this is the project from GitHub. And now let's say I want to open this in like an editor. So I'm not gonna use Visual Studio Code. My preferred editor here is Atom, which is just another editor to write code in. I'm gonna open up this project in Atom. And yeah, you can see up here, it's under desktop, right? But yeah, I cloned it successfully. So that means I have, let me close out of this. This is hard to work with because there's like a bar at the top, but yeah, so this is exactly the same code as what is under here. And actually with Atom, you can actually see my .git, right? So this is the Git repository folder. So yeah, I've successfully cloned everything on GitHub onto my local machine, right? Right now, this is Mike speaking. Cool, so I've cloned everything. And now let's say Mike wants to add some code, right? He doesn't like just an empty void error function. He wants to print something out. He wants to print, I am the best coder in this group. He's gonna save. You can see under version control, these files are different color every time you add something. And now let me go back to GitHub Desktop. What's nice about GitHub Desktop is you can see all of the changes you've made, right? So here, the most important changes here, right? The system.out.print, and you can also see the changed files. So basically, GitHub Desktop automatically does your git add period. So now I have to, after git add period, I do a git commit, right, with a message. Let's say the message is Mike, oh gosh, I don't know, demo GitHub Desktop. You can have a longer description here. That's unnecessary in this case, but I can commit to the main branch by just pressing this button. And now I have no local changes because, again, I've committed them. They're ready to be pushed. And I can push origin. And after a bit of time, all right, I should have successfully pushed everything. So now if I refresh this, you'll see, hey, look, 21 seconds ago, I added a commit, or I committed under this message, and I added this code right here, right? I'm the best coder in the group. Let me just make sure. Does anyone have any questions about that? Okay, if not, I guess I'll demo polling with GitHub Desktop. So we've already gone over pushing, right? Now let me, all right, now Mike's done with his assignment, right? Now it's back to, it's back to me. I'm gonna first poll everything. This is always good practice to get the most updated and working project. I'm gonna clear my terminal. And then I'm going to add some code now, right? So public, gosh, I'm just adding, let's add a comment. All right, those are easy to write out. I'm going to save git status. I've modified this file. Now I can add this file to the staging area, commit it with this message, right? Again, it's like a pretty repetitive process. So added comment and then push. Okay, so I've pushed. If I refresh, you'll see this update. And now I'm back to Mike. Okay, so now let me go to GitHub Desktop, right? Currently, I don't have the comment in my local machine, right, on my desktop. I can pull really easily by pressing this button right here, fetch origin, okay? If I press this button, you'll see, hey, look, there's something on the remote GitHub branch that doesn't exist on my local computer. If I click pull origin, hey, there it is, right? The comment that I added. And now everyone's synced up and happy. So yeah, GitHub Desktop is really easy and it's really easy to use. It's basically just changing the file on your computer, writing the commit message, committing it to main, and then pressing this button here, and then or like a button here, and then to pull again, you can just press this button. So yeah, definitely, I'd recommend if you're new to Git, you can always start off with GitHub Desktop. It'll make transitioning to using the command line a lot more intuitive. Yeah, does anyone have any questions? Okay, no, that means either I'm doing a really good job or a really bad one. Let's see, what should I do now? We have a bit of time left. I guess we can go over branching. Okay, so for branching, so I guess let me backtrack. So earlier we ran into like a merge conflict, right? Because like Anika pushed code onto GitHub, and then I tried pushing my own code onto GitHub, and the two lines that we changed were the same. So Git doesn't know which line is which version is the working one, right? With branching, Anika kind of referred to this earlier. It's basically just grabbing a clone or a copy of the code and then creating, again, a new copy of it that you can work off of. For branching, actually, I'm going to go back to the command line because I don't know how to.
So right now, everything we were doing was on the main the main branch.
Yeah, exactly.
Okay.
Mm-hmm. Yeah, so here you see there's only one branch, right? I'm going to demonstrate branching in the command line because I don't know how to do that in GitHub Desktop, but the command shouldn't be that bad. So first I'm going to do git branch. This just tells me first which branches I have in this project and which one I'm currently on. So right now, again, I only have one branch, right? And I'm currently on the main branch. What's nice about VS Code is you can also see which branch you're on the bottom left here. But let's say that this is a really big project and I have like a backend part of it, right? I can create a new branch by doing git checkout -b. -b stands for branch, and then the name of the branch. So let's say backend is the name of this branch. So if you type that in, it actually automatically switches to your backend branch, as you can see here. And if you do git branch, you can always navigate between branches by doing git checkout and then the name of the branch, I think. Right, yeah, so I switch to main branch. If I do git branch again, I'm on a main branch. But yeah, let me go back to my backend branch. Sorry, git checkout backend. And let me just clear it because there's a lot of stuff there. So now I'm on my backend branch, and let's say I want to test some feature, right? I want to develop something that I'm not sure will work, but it'll be cool to see if it works on my local. So let's say public static Boolean backend return false. if I save this, I can actually, again, if I do my git add, git commit, added backend, and if I do a push, okay, so backend to backend. One thing you'll notice is, let me clear this again. Right now, my backend is exactly what it says, right? Like I have these 4 functions or methods. But if I were to go back to my main branch by doing git checkout main, you'll see the function that I just added no longer exists, right? So this is really cool because most times the main branch will always have working code. So since it always has working code, if I were to like test something on my backend branch that doesn't work, I can just immediately erase this branch and pull everything from my main branch, you know, to get the working code. But yeah, so that's pretty much it for branching. Now let me go back to GitHub. Okay, you see that I recently created a branch, and you can click this button. But before I do that, let me refresh. Notice this number changes from 1 to 2. If I click on this branch here, I now have a backend branch. So if I actually right now I'm on my main branch, right? The main branch is the working version. It doesn't have the function that I just added. If I were to switch to the backend branch, this backend branch now has this function, right? So let me go back to my home, go back to main. Now I can compare and pull. So you might have heard about like pull requests before in like industry. What this is it basically just compares all the branches you have and allows you to merge them safely. Right here, right? You're able to merge automatically these branches. This is because if I were to merge these branches, there wouldn't be any merge conflicts or any lines of code that are like, you know, being changed by like 2 different people. Sometimes if I have a merge conflict, then this will be a red X and I'll know that, hey, like I should step away from this or like I should revert back to another commit. But yeah, this is what it looks like to open a pull request. You can have the description here, the title, and then you can write a comment. Let's say added a function. If I click on create a pull request, I'll have this, right? It's first going to check if I can merge it. And then if it sees that there's no git conflict or merge conflicts, then it'll tell me this. And this is really cool because I guess like in industry, like, you know, if you're working with a lot of different engineers, normally your supervisor or like someone higher up than you will check out your commit history and then approve this pull request. They can do that by going to commits and then, you know, clicking this commit. And then, hey, like they can see what was added. They can review all this code, see if it has any like syntax errors or like any like, you know, stuff like that, any semantic errors or whatever. Same thing with like hackathons. You can ask someone else on your team to review your merge request. But since I'm the only one on this project, I'll self approve my merge pull request. So I can do that by clicking this button and then writing the comment. So like approved. Sorry, no, I have to confirm this merge first. Confirm the merge. Okay, cool. I actually don't need this. So now, yeah, the pull request was successfully merged and closed. I could delete the branch, but for now, I'm just going to save it in case, you know, I want to work on the backend branch again. So if you remember before, the main branch didn't have this function, right? It only existed on my backend branch. Now, however, I'm under my main branch and you can see this commit message, right, from 4 minutes ago. If I click into this file, you can see, hey, there it is. I've merged the 2 branches successfully. And then I can always do a git, sorry, I'm in my backend branch. If I check out to main, I can do a git pull and then everything on GitHub everything that's working under the main branch is on my local machine. Yeah, I think that's all I wanted to go over today. Does anyone have any questions? I know we went over a lot, but hopefully that made some sense.
I just have a question. Like, do you give yourself like lots of pats on the back because you have Eddie Shoe rocks and you and you approve your own merge request?
Yeah, I mean, is Christian here? Hold on. Oh no, he left. Yeah, some of my friends would say that, but I try to stay on I guess. I don't know. All right, I'm gonna stop sharing. All right, yeah. Anyone else have any questions?
So when you were using the command line and you got a merge conflict, it kind of like yelled at you when you used, I think, commit, right?
Mhm.
Is there like a way to check for like if there would be a conflict before you even type commit? Or do you have to wait for that?
Yeah, that's a good question. So I guess first we should talk about like avoiding these errors. To avoid them, just simply don't change the same files at the same time. But technically there's no real way to know if there is going to be a merge conflict. I would always, again, pull code before you change anything. So like do a git pull, right, to get the latest version that works. Yeah, committing, like merge conflicts are like the biggest meme in the industry. Like everyone runs into them. Yeah, but hopefully these merge requests and like branching will kind of solve them. Yeah, good question.
Wait,
Thank
so
you.
merge conflicts? Okay, so I have like an analogy with like iterators. So if you like remove an element without using the iterators remove, and you click and you do iterator.next, that causes like a what do you call it, simultaneous what do you call it? It's like you can't do those operations at the same time. So are like merge requests something like that?
Yeah, that's one way of thinking of it. It's basically trying to like push and pull a door at the same time. There's, bound to be some error. But yeah, that I'd say that's a good analogy. Yeah. But yeah, good question. Anything else? Okay. If not, yeah, thanks for coming to this session. I know we went over a lot. I'll try to edit this recording and send out the link to those who weren't able to attend, or if you just want to review.
Oh wait, do I have to register on campus groups? Because I didn't register. I just like came through your Zoom link. So do I have to register on campus groups to receive the recording?
Yeah, I can actually just add you. What's your case ID?
DMS 310.
DMS 310.
Yes.
Okay, cool. Yeah, I'll just add you, and then I'll send the email through campus groups. But yeah, how did you find out about this if you weren't in the?
I'm in the developer student club, but I didn't like register on campus groups for the event.
Gotcha.
Because you like sent the link in the email.
Yeah, gotcha. Yeah, no, like again, like our club is like a part of a bigger organization, and like I mean it's Google, so like they have so many like strict policies. It's pretty annoying, but yeah, I mean they provide a lot of resources for us to like hold workshops like this, so it's all worth it, I guess. But yeah, any last minute questions? If not, Anika, could you stay after for a few minutes? Okay, cool. Yeah, again, that's all we had. Thanks for coming and have a good weekend.
Thank you.
Thank you. See ya.
Thanks for coming.